Let's work the problem. All right, let's work through some problems together. Let's get my pen. Okay, so there are 5 applicants for a medical transcript position. The following shows the applicants' results when asked to type a chart. So we have our applicants, we have their words per minute and their mistakes. We first need to identify which is the X variable and which is the Y. In this case, our words per minute will be our X and our mistakes will be our Y. We can't have mistakes without actually putting in words, so we know Y is dependent on our X. The next thing that we're going to do is we're going to find the following terms. And we have a lot here that we do need to find. So I highly encourage you to utilize your calculator to find these. N is going to be the total number of samples that we have. And we have 5 applicants, so N is going to be 5. Next, we're going to take the sum of X. So we're going to add up all these values together and get a total of 219. Then we'll add up all the y's together and we'll get a total of 50. Then we will take our x times our y and then add up all of those numbers together. And we will then get 2,281. We'll then square all of our x values and sum them all together. And we'll get 10,711. We'll do the same thing for y, 570. And then for the last two, we will take our answers that we got up above. So 219 for the sum of x and square it. So that's 47,961. And the sum of y, which was 50, and square it, and that's 2,500. Now, we can do that all by hand as I presented to you in the lecture, or you can utilize your calculator to help you. So we now need to enter all of these data values into our calculator. So we'll press Stat, go to Edit. If you have data in here, you'll want to clear that data. And then let's go to List 2, clear that data. We will then enter in our data values. So we have 24, 67, 53, 41, 34. Let me go over. And we have 8, 11, 12, 10, and 9. Then you want to double check to make sure that they're all in there correctly. Okay, so now we want to find each of the different parts. So the sum of x, the sum of y, the sum of x times y. So we can use this to verify what it is that we're looking for. So to do that, we're going to press second stat, and we're going to go over to math, and we're going to use the operation number 5, the sum. Ooh, sorry. First, you need to quit out of your table. I didn't quit out of my table. So next we'll press second stat, go to math. The operation that we're using is in number 5. So we're going to select number 5. Now I put all of my X in my list number 1. So now I'm going to go select my L1. So second stat, select L1. I want the sum of all of my X, and I'm going to press enter. Then I want the sum of all of my Y's, that's an L2. Okay. Then I want the sum of my X times my Y. So I'm going back over to math. So list 1 times list 2. Then I want the sum of X squared, the sum of list 1 squared. Then I want the sum of y, so that's list 2 squared. Then I want the sum of x squared. So I already found that value. That was all the way up here, so I'm going to go grab it. Put that in parentheses, squared. Then I want to do the same thing for y, so that would be my list 2. I go up, scroll up, and grab it, bring it down, and square. Okay, and so these are all the same values that we got if we were to have done it by hand. So now we need to find the correlation coefficient. Okay, so we now need to locate our R formula, which is n times the sum of xy minus the sum of x times the sum of y divided by the square root of n times the sum of x squared minus the sum of x squared. Oh boy, x squared times the square root of n times the sum of y squared minus the sum of y squared. Okay, so we'll enter in our value. So we know n is 5. xy is 2281. Then we have 219. 50 divided by the square root of 5 times 10 and 711 minus 47961 minus, I'm just substituting it. Oh, there's no minus here. It's the square root. I'm just substituting in my numbers from my table. The sum of y squared is 510 minus sum of y, that's 50. So 2,500 is the one at the bottom. Okay, when I simplify this some more, 5 minus 10,951, then I'll get 5,594, and I'll get 50, which equals 0.86. Okay, and that is R. Alrighty. So now we're going to use the same data and we're going to find the slope of our regression line. So M equals n times the sum of xy minus the sum of x times the sum of y divided by n times the sum of x squared minus the sum of x squared. So we'll use the data that we got. So this would be 5 times 2,281 minus 219 times 50 divided by 5 times 10,711 minus 47,961. Okay. You can enter in the whole numerator and the whole denominator into your calculator. You should get 555 in the numerator and 5,594 in the denominator, which gives you approximately 0.08. So B is our y-intercept, and that is the sum of y minus m times the sum of x divided by n. So that will be 50 minus 0.08 times 219 divided by 5. Okay, and that will approximately be 6.5. 6.5 when we enter that into our calculator. Okay. So now let me show you on the calculator how we would find our M and our B. So we already have the data points in our calculator. Okay, so what we're going to do is we're going to go to Stat, we're going to go over to Calc, and we are going to go to number 4 and select Enter. In number 4, we are going to put our X list, which is L1, and make sure that's selected. For our Y list, we are going to select L2 because that's where all of our Y data is. We'll keep the next 2 rows empty and go down to Calculate and press Enter. Now the values that we get here is going to be in the format y equals mx plus b, where a is going to be 0.08, which is what we got, and our b is going to be approximately 6.44, or when we did it by hand, it changed things because we rounded our 0.08, but on the calculator we get 6.44. So you can use either one, 6.5 or 6.44. Okay. Now in this screen, we also can get our correlation coefficient, but in order to do that, we need to activate the diagnostic. So I'm going to run through those steps. So let's go second mode to quit out of that screen. The next thing we're going to do is go to catalog, which is right above 0. So we'll press second 0. We now want to get down to the letter D. So we can scroll all the way down, or we can select D. And D is right here in green. So I'm going to press alpha, the D value. And I want to go all the way down to diagnostic on and press enter. So your diagnostic is on. Now when you go to Stat, Calc, and then number 4, go all the way down to Calculate. Now you will also get your R, which is your correlation coefficient, which is the same value that we got when we did it by hand. Okay. So we can now write our equation, which is going to be y equals 0.08x plus 6.4. Okay, so we're going to change this to 6.4. Okay, so that's our regression line. Now we can use our equation to make predictions. So if our equation is y equals 0.08x plus 6.4, and we want to know the number of mistakes someone would make if they typed 47 words per minute, well, we know words per minute is the x, and we know the number of mistakes is y. So we're trying to find y when we're given x. So this will be 0.08 times 47. Oh, that shouldn't be a plus then. Or equals, that should be a plus. Plus 6.4. We will enter that in our calculator, and we should get y equals 10.2 mistakes. So that would be rounded to 11, because you can't make 0.2 of a mistake. The next one, go back to our regression equation first. We're trying to predict how many words per minute someone would type if they made 14 mistakes. So now we're given y, and we're trying to find x. So we're first going to have to subtract 6.4 from both sides of our equation. And we should get 7.56 equals 0.08. Then we'll divide both sides. By 0.08. And so we get X equals 9.45 words per minute, which is roughly 10 words per minute. Okay, awesome. 10 students were asked how many minutes they studied for a certain test. Their responses and their test scores are shown below. Create a scattered plot of the data. So we have the minutes studied, so that will be our X, and then the grades. The grades are going to be dependent on how many minutes they studied. So we need to plot all of these ordered pairs. So we have 20-30, we have 40-40, 50-40, 60-20, 60-60, 60-95, 70-75, 80-75, 90-90, and 90-95. Okay, so X is going to be the minutes study, and Y is going to be the grades. Okay, make sure that you label your axes. Okay, so we're going to now find our correlation coefficient, and we're going to utilize the calculator to help us. So let's go to our table, and we are going to enter in all of our data. Okay, so we have 20, 40, 50, 60, 60, 60, 70, 80, 90, 90. Okay, enter the Y's, 30, 40, 40, 20, 60, 95, 75, 75, 90, and 95. So now we want to go get our linear regression line. So we'll go over to Calc, number 4. Everything should already be set up from the last problem. And we see here that our correlation coefficient is 0.75. We want the equation of our line. So this is in the form y equals mx plus b. M is 0.95. B is 2.84. So y equals 0.95x plus 2.84. We need to use our equation to predict the test score of a student who studied for 30 minutes. So test scores were the y, the studying time was the x. So we're going to substitute in 30 minutes and then simplify the right-hand side, which will equal 31.34, which is 32 minutes approximately. Okay. Next, we'll use the equation to predict how many minutes, which is x, if they scored a 50. So now that's the y. So 0.95x plus 2.84. We're going to need to subtract 2.84 on both sides. These cancel. So I'm left with 47.16 equals 0.95x. Divide both sides by 0.95. And x equals 49.64. So this is roughly between 49 and 50 minutes. Alrighty. Great. All right, why don't you pause the video and then come back and check your answers. So I want you to attempt these problems use your calculator and see when you come back what you got right. Okay, welcome back. So in our problem here, we have data that represents a set of heights and weights for women in America. So our heights are going to be our X and our weights are our Ys. So hopefully you put all this data into your calculator. So all of the X's are in one list, all of the Y's are in another. When you did that, you should have gotten the equation y equals 61.27x minus 39.06. You should have gotten your correlation coefficient as 0.99. So this is a very strong positive correlation. Oh, wow. Then for your predictions, you should have gotten y equals 57.13 kilograms. So you would have taken this 1.57 and substituted it for x because we're trying to find y. And then for D, you would have gotten x equals 1.62. And you would have substituted in 60 for your y because we're trying to find height, which is our x. All right. All right, and this would be in meters. Okay. And that concludes our practice.